Okay, students, very warm good morning to all. This side, we are mentor, here teacher, Mr. Jagdish Mahantu. Today, I am going to discuss the seven-state process model in OS. So, before we proceed to the process life cycle state diagram or process life cycle, so we have to know what is process and what is the role of process in operating system. First thing ki the process management is one of the most important function of the operating system. So this chapter is very important for us, for exam point of view, for semester point of view. This is very important. So first of all, we should know ki what is process. Process means actually it is a program which is in the execution state. So whatever we tasks provided to the computer or provide to the computer, that is known as task. But inside the system, we cannot say that is task. That is a student's process that becomes process inside the main memory. Okay, so whatever the tasks we provide to the computer, that is known as a process. The number of tasks equal to number of process is created in the in our memory. So the main role of operating system here to create a process and execute a process. That is the main role of the operating system here. In the process life cycle, we are going to learn how process are created, what are the states are there in process life cycle, and how finally process is going to execute. So that things now I am going to discuss. If you guys are any doubt, you just mail me, ping me. I will definitely help your query, help your doubt. Okay. So you see just in the above diagram, there are various states are there in the process state diagram. Like you see here, new states are here, then ready states, running states, exit state, block state, suspended block state, suspended ready states. So now I am going to discuss one by one states and its rules and how the state process states, different states play a crucial role in the process life cycle. Now I am going to discuss. Here you see three students. There are, let's say, new states and suspended ready state and suspended block state. Student, these three states are occupied memory from the secondary memory. And the rest three states like ready state, running state, block state, the three states are occupied in the main memory. Means memory the main memory can allocate memory for these three states. Okay, and the secondary memory can occupy or is allocate memory for above the three states. The first state is, that is students, you see in the above diagram the transition or the arrow mark between the two state. You see fast new state to we can go or process can go new state to ready state to running state to exit state, running state to again come back to the ready states, running state to block state to ready state, block state to suspended block state, again suspended block state to block state, suspended block to suspended ready, and suspended ready to ready states, and ready state to suspended ready. Vice versa transition can happen in the above diagram. So Let us discuss one by one states and its role in the process life cycle state diagram. Okay, first state students, new state and ready state. In the new states, what happens, students? The process are created. The new process are created in the new states. Okay. So first transition is, student, that is new to ready state. In this case, what happens, students? When a process is created, it is a new state, no doubt. It moves to the ready state when the operating system has allocated resources to it and it is ready to be executed. So this happens between new and ready states. Next, student, that is ready to running states. See, student, ready state means in the ready states, this ready state is inside the main memory, or you can say RAM. Whatever the students process comes from new state to ready state, that are in the queue form, that are stay in the queue in the ready states. And ready means the process are ready to go or ready to dispatch to the running state where CPU is presented. The CPU is executed one by one process, and so CPU can accept one by one process and finally execute it. So next transition diagram, that is ready to running state. In this case, in these two states, what happens, students? When the CPU when the CPU becomes available, the operating system select a process from the ready queue depending on various scheduling algorithm and move it to the running states. Okay, so in between ready state to running states, there are various algorithms are there. Various algorithm can be used, that may be preemptive and that may be a non-preemptive. So preemptive means what happens, students? Preemptive algorithm, if we apply the preemptive algorithm in between ready state to running state, what happen? Each process can get or can same amount of time. Okay, that means time quantum are there in the what the preemptive algorithm cases. So CPU what can do in the preemptive cases? Each process, let's say the time quantum is 2 millisecond. So in the running state, CPU can provide or CPU can execute 2 millisecond for each process. If 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 the process is fully executed in between 2 millisecond, then it's no problem. The CPU finally release that process to the exit states and the process is come out from the entire scenario. If any process is not executed within the 2 millisecond, the CPU what happened? The CPU what happened, students? Again sent to the ready state. That is called, students, context switching. This term is known as a context switching. Okay. Next, students, we are going to discuss another two states, that is running state and block state, students. Running state and block states. Let's say कि one process is going to execute by CPU in the running state, but the process wants to the some input output occurs. Means some let's say कि and the process is a program and the process needs some input, so it will time consuming. So what happen? The CPU do not wait for that particular process. The CPU send that process to the block states. Okay. So here block states rule is, if any process wants to the input output operation or want to some system call, then CPU send that or send those process to the block states. Okay. Next, students, that is called running state to ready states. I have already discussed, when a running process is preempted by operating system, it moved to the ready state. For example, a higher priority process become ready to OS may preempt to a running process and move it to the ready state. Next one is student, that is block to ready. Block to ready. So when the events a block process was waiting for occurs, the process moved to the ready state. For example, a process was waiting for the user input is provided, it moved to the ready state. I have already discussed कि if the process want to the some input data for its program, then the process waits in the block state. After getting input data, the process again move to the ready state. Okay. Next student, block to ready state. I have already discussed. Next students, that is uh, running block states. Block state to suspended block state. See students, block states is already present in the main memory. The size of the main memory is very less. So here the limited number of process can reside here or stay here. If the number of process is increased in the block state, the block state send that process to the suspended block state, which is again it is in the secondary memory in the virtual area. Okay. So this is the scenario. This is the relation between block and suspended block states. And again, students, you see there is a mapping between the connectivity between the ready state to suspended states. You see, students, in the ready states, the area, the number of how many number of process can stay in the ready state, that will decide the long-term scheduler. Means how many number of process can be allocated in the ready state, that is decided by long-term scheduler. If the number of processes increase, then what happen? The ready states send that processes to the suspended ready states. If the ready states becomes blank or vacant, then again that process again move from suspended ready state to the ready states. Okay. So here the I think all the runnings, all the states I have already mapping and discussed together. So here there are some again which there are some terms we are going to use or has been used, that is called student long term scheduler, middle term scheduler and short term scheduler. The long term scheduler is used students in the ready states, means how many number of processes can stay in the ready state, that will decide or that is decided by the long term scheduler. It is called multi-programming or multi-programming. Okay, it is called students multi-programming. Multi-programming means the number of process can how many number of process can stay in the ready state, that will decide by or that is decided by the ready states. Okay, the just long term scheduler I have already discussed. Next student, that is short term scheduler. Short term scheduler is student, the other name of short term scheduler is that is called dispatcher. So the role of CPU dispatch, the CPU scheduler, you can say that key. So the short term scheduler, the main task is from the ready states, the short-term scheduler picked one by one process and send it to the running states. In the running states, CPU is there. CPU is finally it is executed, then terminate to the and exit terminated into the exit state. Okay, that is the role of students short-term scheduler and mid-term scheduler. So students that is middle term scheduler, that is the middle term scheduler is the main task, that is middle term, that is in between block state and suspended block state. If the number of processor increase in the block state, the middle term scheduler, what happen? Send that blocks to the suspended block states. So it can the main task of middle term scheduler I have already discussed. Students, next here we are just going to discuss some like terms like preemption and non-preemption. See student, in between ready states and dawning states, there are various algorithm are used by operating system, that is preemptive algorithm and non-preemptive algorithm. Preemptive algorithm means students, suppose a preemptive algorithm has been used or is used in between ready state to running state. Preemptive means whatever the if primitive algorithm use, let's say the one example of primitive algorithm, round robin algorithm. Round robin algorithm we are going to use in between ready to running state. So what happens, students? If primitive algorithm is used, each process gets equal amount of time to execute in executed by CPU. During that time, if any process is not executed completely, then CPU, what happens, student? Send it back to the ready state, that is known as, student, context switching. So in the primitive case, the whatever the process comes from ready state to running state, each process gets equal amount of time. If during that time the process is not executed, again resend the running state for the CPU, again resend to the ready state. That is called preemptive preemption or context switching. So the main algorithm of preemptive algorithm, that is known as round robin algorithm, and any other algorithm also there. Next, student, non-preemptive. Non-preemptive case means, students, if here the non-preemptive algorithm has been used or is used, what happens, students? In case of non-preemptive cases, let's say one process moved to the running state. The here time quantum is not matter, does not matter. The CPU is fully executed, that process, then another process can come from the ready states. Means here no time barrier is here in running states in case of non-preemptive cases. So this is the difference between preemptive cases, preemptive and non-preemptive cases. The non-preemptive algorithm are, that is called, students, what? Fast come fast serve, FCFS also there. Okay. Next we can, student, that is called multi-programming. Multi-programming means how many process can stay, how many process can run. Okay. How many process can, we have many processes ready to run. There are two type of multi-programming, preemption and non-preemption. Okay. No problem. Next, degree of multi-programming means, students, degree of multi-programming means the number of process can stay in the ready state. That is called degree of multi-programming. Let's say ki one example is, that is called, let's say ki there are 100 process are there in the ready state. That means the degree of multi-programming is here 100. So again, just I am finally just give a small idea. The here in the new cases, the process are created, then the process move to the ready states. Okay. Again, ready means now process is fully ready. The process has already get some what resources, and the process is ready to move from ready states to running states where CPU is there. If CPU is fully executed, then CPU is just terminated, or the CPU is just out of scenario by the help of exit state. If the process is not fully executed, then again it come back to the ready states and waiting in the queue. Okay. If the process in the running state, if the process want to the secondary IO operation, then CPU send it into the block states. If the block states, if the area of the block space or if the memory of the block space is not sufficient, then the process are again moved to the suspended block states. So again from suspended block state to can move from block state and block state to again ready state. So I think I have already discussed all the things like whatever the in the above scenario, whatever the states are there, I have already discussed briefly. Okay, so next we just move to the just I have already discussed things. So next I am just move to the just some overview or some highlighted things now I am going to discuss. We have already discussed the how many process states are there, like new state, ready state, running state, block state, terminated state, suspended ready, and suspended block. And state transition I have already discussed, from new to ready, ready to running, running to block, running to ready, block to ready, running to terminated. Okay. Ready state I have already discussed. Running, ready to running, short term scheduler peaks process. Okay, a new state ready process admitted by the scheduler. Running ready permitted by the highest priority process. Block. So type of scheduler here we use that a long term scheduler. Long term scheduler means control number of ready processes. Short term select a process for a CPU frequently. Medium term swap process between secondary memory to primary memory. Okay, and multi-programming. There are two types of multi-programming happen, that is preemptive and non-preemptive. Okay, and degree of multi-programming we have already discussed. Max ready to the process, that is 100. Process operation, creation, fast process creation, next scheduling, next execution, next blocking, resumption, deletion, context switching. Okay. Next process control block. Process control block students you see कि if we provide number of tasks to the computer. So PCB, what happens? PCB stands for process control block. So inside the process control block, students, each process, how many number of process are created? If the number of, let's say the 100 number of process are created. So in the PCB, different 100 PCB ID are there. Okay, so in the PCB, you can say कि control room where which process is in the which state, that we can know from the PCB, and which process is already created, that information also we can get from the PCB, and which process is already executed and get out from the entire scenario, that information also we can get from the PCB. Okay, the PCB, the data structure which maintains what are the events are occurring or happening in the above transition diagram or above blocks diagram. That information we can get out, or operating system can get out from, or get from the PCB. Okay, the PCB is also very important. Next, feature of states. Only new and terminated can occur. Ready, running, waiting states are revisited. New and terminated occur one, students. We cannot revisit new and terminated states. And ready, running, and waiting states are revisited. Terminated can happen from waiting about it. Scheduling algorithm decide transition. Scheduling algorithm means what type of algorithm we are going to use in between ready state to and running state. Visualize after the process diagram. Next, conclusion. State help operating system manage processes efficiently. Transition in your resource sharing and multitasking. Seven state model is a key to the operating system performance. Okay. So I hope ki, I have already clear your doubts. Okay. So if you guys have any doubts, you just contact me. I will definitely help you. Okay. Thank you. Thank you for your watching. Bye bye. We'll meet you another video. Till then, bye bye.